Okay, here we're going to go through and identify the functional groups in this compound. Alright, so we'll kind of start here on the left, and we have this cyclic six-membered ring with alternating double bonds. So this is just an aromatic ring, or we'll call it an arene. And we actually have three of these benzene type aromatic rings. Okay, and this one, you might even see it called an aryl fluoride, because we have the aromatic ring with the fluorine, so it's sort of considered an aryl group, which is a derivative of the arene. Alright, next we have this C double bond O. So remember that any C double bond O is considered a carbonyl. But the carbonyl has subclasses: ketone, aldehyde, ester, amide, carboxylic acid. So in this case we have our C double bond O, we have it connected to a carbon, and we have it connected to a nitrogen. So since one of our connections here is a nitrogen, we call this functional group an amide. Okay, next we have this nitrogen. So we could actually give this a couple different functional group names, but we'll keep it simple for now and just consider this as a nitrogen with 3 bonds to carbons, so we'll just call this an amine. Okay, you might learn later on that this nitrogen in this 6-membered ring, or in this nitrogen in this 5-membered ring, is a pyrrole functional group. Okay, next we have 2 alcohol functional groups. Or you can call them hydroxy groups. And then here at the end we have another carbonyl group, but this time we have a bond to a carbon and a bond to an OH. So with this connection to the OH, this carbonyl is a carboxylic acid. Okay, so just to kind of review some of those carbonyl groups that you might run across. Okay, if the carbonyl has a carbon on both sides, it's a ketone. If one of those carbons gets replaced by a hydrogen, it's an aldehyde. If we have an OH like we did above, it's a carboxylic acid. If we have an oxygen, but instead of an OH, we have some sort of carbon chain connected to that oxygen, it's an ester group. And then if you have a nitrogen, this nitrogen could have just 2 hydrogen attached or carbons attached, just like we had here. We had a hydrogen and a carbon group attached. This is an amide.